Alright, so for now, we are going to talk about the solution for the smart farming. So one of the solutions is by using the first is serological method. So serological method is a plant virus identification method that is based on the specific reaction between the viral antigen and their specific antibodies. And also example of serological method are enzyme-linked immunosorbent assay, or which are known as ELISA. And ELISA is a plate-based assay technique which is designed to detect and quantify peptides, protein, antibodies, and also hormones. And also in ELISA, an antigen must be immobilized to a solid surface and then complexed with an antibody that is linked to an enzyme. And this detecting method is a highly specific antibody-antigen interaction. And also the sensitivity of ELISA varies depending on the organism, sample freshness, and also the titrate. Thanks to the advancements of technology and ICT, they are now available for numerous taxa of phytopathogenic bacteria, and now rapid detection kits are commercially available. So for the second one, we are going to use a nucleic acid based method. So it is a plant pathogen identification through organism specific DNA or RNA sequence that are extracted from an infected plant. And as the name suggests, the solutions are DNA based. An example such as fluorescent in situ hybridization, FISH, RNA reverse transcriptase, and also the which we are going to focus is a polymerase chain reaction, PCR. So in the PCR method of testing, DNA is first isolated from the sample. Then individual genes are then synthetically produced in the laboratory and they are labeled with special fluorescent tags. And these fluorescent tags enable the detection of genes. Also in the PCR-based diagnostic, we are using primers for DNA amplification and detection. The presence of amplification product confirms the presence of organism in the tested sample. And also we are going to use SYBR green detection, which are less toxic and more sensitive method. And generally, this PCR can be performed in 2 or 3 hours, but thanks to the advancements in technology and ICT, they are now can be delivered in minutes. And also this PCR method is one of the most practical methods for plant and virus detection. For the third method, we are going to use the geographical information system. Have you ever used Google Maps or maybe Waze in your life? Surely it can help you to reach your destination easier and faster. So GIS is a computer system for capturing, storing, checking, and displaying data related to position on Earth's surface. This GIS can show many different kinds of data on one map, such as streets and buildings, but more importantly, it can include information about the landscape, such as the location of stream, different kinds of vegetation, and also types of soil. And by using GIS, we can know which crop should be planted where and how to maintain soil nutrition so that plants are best benefit. By using GIS, we can also evaluate for plant pathogen or disease on maps. So this map shows disease activity and distribution, which can help us to take appropriate action. And when disease is encountered, such as developing plant disease distribution map and detecting pathogen genotypes for a better management of plant disease. And also the use of GIS in agriculture can surely help farmers to achieve increased production and reduce costs by enabling better management of land resources. And a correct identification by using GIS can lead to the best control measure and can save time and cost for farmers. For the fourth solution, we can use a clustered regularly interspecies short palindromic repeats, now known as the CRISPR method. So it is a method used for genome editing of any organisms. It allows researchers to easily alter DNA sequence and modify gene functions. Its many potential applications include treating and preventing the spread of disease, and also to create more resistant plants. So how it is done? So the protein of the CRISPR is an enzyme that acts like a pair of molecular scissors capable of cutting strands of DNA. Once DNA is cut, the researcher uses the cell's own DNA repair machinery to add or delete or maybe make changes to DNA by replace an existing segment with a customized one. And also, the application of CRISPR editing has become a powerful tool for future enhancements of agronomic traits in crops. In conclusion, based on the four solutions mentioned earlier, it has been proven that advancement in ICT is very important to ensure greater advancement in the science field.